patience.
I think it's adventure.
I think it's dedication. It's dedication and also loving to solve problems.
Be able to put in the hard work to study and prepare for this competition.
It's hard work.
It is effort.
There is a lot of smart people in the world, but few of them are persistent.
Hi, I'm Ignacio. I'm 21 years old.
My name is Mateus Aires. I am from Brazil.
My name is Xu Wen. I'm from Zhejiang.
My name is Bernard and I'm from Iceland.
My name is Zhen Zihao. I'm a grade 3 university student from Tsinghua University.
My name is Masaka Yoneda.
My name is Hirotaka Yoneda.
You're at the ICPC Championship powered by Huawei. We are facing huge challenges, just waiting to be solved by the best of us.
The business of helping people prosper, for there to be enough and more than enough.
I'm excited to see what will Huawei bring us next.
I am very excited for the contest.
I'm excited and a little nervous.
I feel a little nervous because it is the first time in this year to participate in a big contest.
I have the experience to get second place in international optimization contest.
I also aiming to become top 3.
I think I will get into the top 10 because I get the top 10 in the previous contest.
These type of challenges are really hard.
When I join a competition, I don't like to lose. I usually join to win. I want to come at first position.
Mostly known for 5G and like internet related stuff, but we got to know that they're also doing like some solutions for car, and I found that quite cool.
There are a lot of high technologies in Huawei.
They have a lot of products over all sorts of businesses, and it's a very large company.
I thought that they are doing for the scientific innovation for the society.
We see that Huawei is very committed with doing better, with improving and with innovation.
Because Huawei is a name that people trust to provide their communications and services. And that's actually why I'm right here at headquarters in Huawei.
I made the result a bit better of him.
I finally got 31st place.
Not very well. I got the 18th.
Today I got 14th place, and I think I'm satisfied with that.
I won the competition. I was first prize because I got some recognition of some very good people, so I was happy about that as well.
Huawei problems are really focused on real life, so I think it will help people in the future.
The problem is buffer sharing and reallocation problem. One of the bottlenecks of computer speed is about memory. So, what happens if computer speed is going up? Not only our computer becomes fast, but we can do many research.
It can improve self-experience of using cloud services.
We're doing it together with industry and community leaders in the small and in the large. And I think that's one of the reasons why Huawei loves to be part of the competition. So we have training camps in a lot of different ways, and actually Huawei sponsors some of those training camps, and also challenges where we introduce problems that don't fit the ICPC model of competition. The ICPC is about creating opportunity for others. That's what I mean by flourishing.
In IOI, there is a rule that we can bring mascots, so I bought it.
So, of course.
I am bad with everybody's name.
Hello everyone, welcome back. How was it today? Are you excited? Are you nervous? And can't you wait to hear what the places are? How did you do today? Are you excited? All right. Well, I have still bad news because we're gonna wait with telling that. Because first we have something very interesting. We're gonna look at the solutions of the problems that you all have been working very hard on today. So for that, I would like to give the word to Maarten.
Thank you very much, Nadine. All right. And now first of all, I would like to thank all of the jury members that have worked hard to create this problem set. A great bunch of them are sitting over there in the orange shirts. Wendy unfortunately couldn't make it, but we also definitely appreciate their efforts. And of course also big thanks to our proofreaders and test solvers who helped us find all kinds of nasty little bugs, edge cases that we didn't think of, and many, many more things. Just like yesterday, we will go over the problems from easy to difficult. And in the top right, you have this nice submission graph again, which shows the accepted submissions in green, wrong in red, and the blue on the right is the pending submissions during the freeze. And the first problem I'm going to talk about is the klompendans, the clock dance. So you were given an n-by-n grid, and you start in the corner of that grid, and you need to check how many squares can we reach during any dance when you alternate between two knight-type moves. And the solution to this problem is basically you need to have two copies of the grid, one for each move that you used last, and then just do a BFS or DFS alternating between these two grids after every jump. And then just count all the cells that are reachable in either of those grids, which gives you an O(n) squared time complexity solution to solve this problem. Before the freeze, 120 of you guys got this problem accepted, and there are still 19 submissions that were made during the freeze, and I hope many of you still solved it during the freeze. For this problem, we had some nice visualizations. So in the blue, all the pixels in blue are the squares that are reachable for some specific configuration of these knight-type moves. Some of them give like a Delft tile-like pattern. We really like them, so we just included them in the solution slides, especially this one on the left. It's really beautiful. For the next problem, date picker. You were given the availability of your agenda for every hour in the week, and you needed to pick at least some days and at least some hours in each poll to get the highest probability that you would be available during this meeting. And I would like to thank Jeroen for struggling with this while we were planning our first jury meeting, because that's how he came up with this problem, actually. First observation you can make, you can just select exactly the days and H hours, because if you select more, then your probability of being available will always go down. And then the first thing you can try is just take any subset of days, and then for each subset, take any subset of hours, calculate the number of free time slots that you have, and then take the minimum over all of them, and then finally divide by D times H, of course. Unfortunately, this is way too slow because in the worst case there can be 3 billion time slots that you have to check. So you need to do something smarter. And actually, if you write very efficient C++, you might be able to get below the time limit, but not many of you tried this. A smarter solution would be to, instead of checking all combinations, just check the combination of the days instead. And then for every combination of days, you count for every hour the number of cells that have a dot, which means you're free. And then for this list of counts, you just sort it and take the top age of them. And for this top age, you calculate the number of free time slots and divide by d times h, and then you have your probability of being available. For this problem, there were 118 accepted submissions before the freeze, and then still 12 during the freeze that were still unknown. Next up, lateral damage. This was an interactive problem. You were playing battleships on a 100 by 100 grid. You need to sink up to 10 aircraft carriers in at most 2,500 shots. But your opponent may not actually place these carriers beforehand, which you typically do during battleships, but they may do this while you're shooting. First observation here is that if you shoot every 5th position in a straight line, then this will prevent your opponent from placing a ship in between those shots in this direction. And then, of course, we need to do this for both the horizontal and the vertical direction. So the solution to this is to shoot every point on a diagonal, and then shift your diagonal 5 positions to the right, and then shoot all points on that diagonal, etc. And then for every position you shoot, the 4 positions on the left, right, above, and below cannot fit the ship anymore. So if you then take a hit, then you're most certain that the ship is there, and you also stay below the limit on the number of shots. And then, of course, if you do hit a ship, you still need to hit it fully, but that's of course obvious. For this problem, there were 111 accepted submissions before the freeze, so also many of you got it right. Really nice. And still 71 unknown. And I see a lot of you still tried it right before the contest ended, so we'll see later if this still got accepted or not. And now I would like to give the word to Paul for the next problem.
Thank you, Marta. I think I need to, oh, it's on? Great. All right. So we move on to problem H. That was the next easiest problem. This one gave you a bit more trouble. So there was quite some incorrect submissions for this. So you needed to find an arithmetic expression given some using some given list of numbers, using multiplication and addition, and the value should be maximized. So I think the clicker sort of moved to the edge of the screen, and I can't move forward anymore. Let's see. Okay, now it works. All right, so for the solution, basically what you want to do most of the time is to multiply all the numbers together, but there's a few cases where you don't do this and instead some numbers, put some of the numbers together as a common factor. Specifically, this needs to be done with the 1s and 2s. And successfully, you will find all the cases that need to be considered. So one of them is if there's just a single one, you add it to the next larger number. And otherwise, if you just look at the ones, you want to combine them in groups of 3. With some special cases here, if there's exactly 2 or exactly 4 of them, then you combine them in pairs. And then if you also have 1s and 2s, then you want to combine 1s and 2s together. And again, you need to do some special cases where if there's exactly 2 1s left, then you combine them with a single 2 into a 4. All right, this was solved 67 times before the freeze, and there were still a lot of submissions during the freeze, so we'll see how many of those are correct. Okay.
So next up is problem A. This is working, right? So in this problem, we have a lot of chargers. This problem was obviously inspired by some people traveling here last year, I suppose. So you have this power strip with sockets of 3 centimeters, and you want to plug in as many chargers as you can. So the first insight is that you put the 2 largest chargers on the ends. That's very simple. And then the next insight is that if there is a solution using K chargers, we can always use the K smallest chargers. And then we can do binary search. So to test if K chargers fit, You first start with those with lengths divisible by 3, then you pair up the ones 1 modulo 3 and 2 modulo 3, because they fill everything. Then you can pair up the pairs 1 modulo 3 with a gap. Then you can just put in all the remaining ones. You do binary search, and you have a runtime of n log n. And then I guess there are some tiny edge cases if there's only a single socket, and maybe depending on your exact strategy, you have a bit more. And you can also do this in linear time, actually, but it's a bit more tricky, I think. So 333 submissions, 60 accepted. Wow, it's quite a lot of wrong answers, actually. So problem F, we're given a fraction A over B, and we want to make it equal to C over D by canceling some digits in A and B. So first, we can just iterate over all subsets of A of the digits that we remove. And then we have A prime. And given A prime and the target fraction C and D, we can compute B prime. And then we can just check if B prime can be made from B by removing the same digits as we removed from A. And I guess, again, you have to check this divisibility condition. You might have to use some large big ints, or you can take first divide by the GCD, and leading zeros are one additional edge case. Again, over 300 submissions, but only 50 accepted before the freeze, and many submissions at the end of the contest. Back to Paul.
Okay. Yeah. Thank you. Okay, next up, problem J. This was about a jogging tour, and essentially we needed to find an optimal path through a given grid of to a given set of points, which was running along a grid, and you needed to compute the optimal angle or find the optimal angle to align this grid with. So this leads to a simpler subproblem where we say we already know how to align the grid, how to orient the grid. And for that problem, one of the things you could try is just brute forcing through all permutations, which is kind of slow, especially if you then later need to do it multiple times. And instead, you can notice that this is essentially the traveling salesperson problem, and this has a well-known DP solution that runs in n squared 2 to the n. So then that leaves us with the original problem where we first need to determine that angle. And for this, the key insight is that the optimal solution will always be such that one of the segments along the path will be a straight line between two of the locations. And with that realization in mind, we know that there's only n squared possible angles that we need to try. So we multiply that on top of our time complexity, and we get this n to the 4, 2 to the n, which is plenty for the given time limit. This was done 25 times before the freeze, and 44 submissions are still pending. Okay.
Oh, and we have some more figures for this.
Oh, right. I guess you can describe them.
Well, just some random figures with Manhattan distances along a changed axis. So problem C, chair dance. I guess we're getting into the bit harder problems now. We have up to 100,000 players sitting in a circle on chairs, and we apply some operations on them. The plus operation rotates all of them by a given amount, and the multiply operation changes their position from seat I to seat I times n, m, modulo the number of seats. And we have this tricky condition where multiple people can end up in the same seat. For example, whatever. If n is even and you multiply by 2, you only end up with even seats. And in those cases, the person walking the least distance clockwise gets the seat, and all the other people going to the same seat are out. And then we have a third query where we have to print who is currently sitting on chair number Q. And so one thing we can do is we can just simulate all this whenever we store a vector of who's sitting on which chair. When we have a rotation or an plus operation, we rotate the vector. With a multiply operation, we just find out who is going to which chair, who is the shortest one, has the shortest distance to walk. And this all takes linear time per operation, and so then this would take n squared time in total, which is too slow. So we need to do something better, and what we can do is we can be quite lazy. So whenever we do a rotation, we don't actually have to rotate the vector. We can just say, keep an offset r, and when we rotate by 5, we add 5 to this offset. And then we rotate by 10, we add 10, so we have an offset of 15. And then when you query, you don't query the asked index, but you go back 15 steps and query there. So that solves the rotation. And for the multiplication, we can do the same, as long as it's collision-free. So you just keep some multiplication m. And so in your vector, you store that this person, we don't apply this operation, but this person at position I is actually at position m multiplied by I plus r now. And then you can invert this modulo n, and when you get a query, you just do this inverted lookup. The only problem is if there's collisions, But collisions only occur when the number of people remaining, when the number you multiply by has a GCD larger than 1 with the number of people remaining. And this you can just, in these cases, you can just simulate in linear time because this number of people remaining is always a divisor of n. And there's only, so this always goes down by at least a factor 2. So you can only have this at most logarithm of n times. Yes. So you get an n log n runtime because, as I said, the tricky part, these collisions can only happen a few number of times. So these you can simulate, and the rest you can do this using this lazy approach. So this was only very few accepted before the freeze. And then we go to problem E, exponentiation, with Niels. Yes, that's the big part.
Okay, I will present solution for problem E. I am not the author for problem E, that was Renier, but I will present it. So in problem E, you have n variables that are initially set to 2023. And then you have a bunch of queries where you exponentiate them with each other. And then you should also compare them with each other. So the first trick in this question, whenever you have these nasty exponents, it's always a good idea to try to take the logarithm and see if it gets easier. So let's do that. Let's do that twice even. Now these exponentiation operations get a bit simplified. You get this yi plus 2023 to the power of the other instead. So each variable gets added to it 2023 to the power of some other variable. And this is a bit easier because if you look at the numbers in base 2023, you can see that an operation will just increment one of the digits by 1. And another good thing is there are only 1,000 operations, and 2023 is definitely bigger than 1,000. So you will never get carries. So each number is just like a vector of its digits, and this is much easier. But the exponents will become really big, so you can't just store the digits themselves. You have to use some clever data structure. So at this point, this stops being a math problem, and it becomes more of a data structure problem, actually. One thing I thought made the problem a lot easier is when you have these update operations, you just create new variables. Instead of actually updating yi, you create a new variable. Because we're gonna need the old value of yi to compare other variables, and it gets really messy if you actually update yi. So just create new variables every time instead. Okay, so now there are a few different ways of looking at how to solve this and what data structures to use and how to do the bookkeeping and so on. But the main idea will be to keep the variables sorted at all times, so you can just compare them really easily by looking up in some table or something what the order is. And the hard part is, of course, to maintain the order. So each variable will have a list which is the positions of its non-zero digits. And these positions will be other variables. And you can now compare two variables if you just look at their two lists and compare them lexicographically. Because we know the order. We keep the order of all the variables at all times. So then you can also compare two variables. And when you create a new variable, like when you have yi plus 2023 to the power yj, if you look at the list of digits, this is just that you take the list of yi and then you take yj as an element and add it to the list. So you just add one thing to the list, and then now you get a new list, and you can sort it, and then you can insert it where it should be in this order, and then you can keep going with all the other operations. So I omitted a bunch of details about how to do all the bookkeeping and so on, but you can just have a sorted list of the variables and use binary search to insert new variables, or you can have a try. There are some different ways. You can probably even solve it in cubic time because the constant factor is quite good. And I have a challenge for you to solve the problem in subquadratic time. But instead of 2023, we can have like 200,023 or something. So yeah, you can think about that. The next problem is something that Ragnar should present.
And this was only accepted 5 times before the freeze. So problem G, Galaxy Quest. So we have like some planets in 3D space with highways between them, and we are on a spaceship. And to travel between 2 planets, we can first accelerate, and then keep our speed, because we're in a vacuum, we just keep our speed, and then we have to decelerate again. And this acceleration and deceleration takes fuel. And then the question is, given these highways, we have to go as fast as possible to a target location, or we have to use as little fuel as possible to reach a target location within time. And the question is, how much fuel do we need? And we get 100,000 of these points and highways, and also 100,000 queries, I think. And so if we fix the path, so we assume that we already know the route we're going to take. Oh, this is a bit much than once. So if a segment is di long, and suppose a segment is di long, and we accelerate at x seconds at the start and x seconds at the end, then you can compute that it takes x plus d over x seconds to traverse this segment. So now what we want to do is we want to minimize the sum of the x, or like we accelerate for x and we decelerate for time x, so we want to minimize the sum of 2x, such that the total time we take is at most t. And if you solve this, you can use Lagrange multipliers, or you can use some physics insights, or anyway, the idea is that if you use a little bit more fuel on one edge and a little bit less fuel on the other edge, that should never be better. So you get some derivative that should be equal to 0. You solve it, you get this equation that all the xi should be a constant multiple of the square root of the length of the edge. So now we can relate all these xi, and the only variable that remains is the c. So we can plug these xi back into the equation in the middle, and we solve this, and we get that c plus 1 over c is this thing here, which only depends on the sum of square roots of the length of the path. So if we know the path, then the only number we care about is the sum of the square roots of the lengths. And if this number turns out to be less than 2, then there is no solution, because this c plus 1 over c is always at least 2. So what we do is we just do a Dijkstra algorithm, but instead of doing the lengths of all the edges, we do the square roots of lengths of all the edges. And then every query, we already know this minimal sum of square roots of d, because we did Dijkstra, and then we can answer queries in constant time. So this was only solved once before the freeze. I quite expected this myself to be quite a bit easier, but it wasn't, I guess. And not so many submissions in the end. Yes. I guess this is like a very standard physics thing, actually, but this is not a physics contest, I guess. So yeah, better luck next time, or somewhere else, I don't know. Yes, next to Michael for the last 2 hardest problems.
Okay, now we get to problem B, where you're given some bricks to build a stable wall. And the first problem is, can we even build one single row of that wall? And that's a well-known problem. It's the coin change problem. So every type of brick can also be interpreted as a type of coin, and then it's exactly the coin problem. And there's a classical DP solution that we can speed up with bit sets, or we can solve it with FFT. And interestingly enough, the bit set solution is much faster in this case. Okay. But now, how do we solve the problem if we already know that there's a single row and we already calculated this DP state where we know if we can build a wall of a fixed width with those bricks? Well, the easy case is if we have a brick which is exactly as wide as we desire our wall to be, because then every row can be equal. Interestingly enough, that's also the test case where most people fail. Okay. So, next case, there's a row which uses 2 bricks, bx and by. Now, we can assume that those are the 2 shortest types of bricks, and that we don't get any fewer bricks of the shortest type by replacement, but without losing all of them. So, in that case, we get a new subcase. If we could remove all of the shortest and instead replace them by some a little bit larger bricks, we can just do that. So in the lower row, we have the shortest block, and then we replaced that with the little bit larger block. And if we do that so long that we don't have any more of the shortest blocks left, then we get 2 rows which fit together. Now, in the other case, we can't replace the bricks, but in this case, we can reverse them in some way. So the shortest blocks in the lower row are on the left, and we move all of them to the end of the row, and again, we get 2 rows which fit together. Then there's case 3. We now have 2 types of bricks which both divide the total length of wall we want to build. And yeah, in that case, we know that their LCM needs to be the total width, so we can just make one row with one type of brick and the second row with the other type, and that again will work. And yeah, the last case is then impossible, no more options work. And we can also simplify this. A solution exists in exactly 2 cases, either the trivial case, where we have a brick of the desired width, or there are 2 bricks that can be part of a solution. Then the solution exists, and so far no one was able to solve this, at least not before the freeze. Okay, problem I. You are given 2 endpoints, and you need to check if one point occurs an odd number of times. This is a really classical problem, and there are 2 solutions to this. You can either sort all the points and then check if the point at the even position and at the odd position are always equal. Or there's also a solution which only uses a constant amount of space. In that case, we hash all those points and just calculate the XOR of the input, and it's 0 only if all numbers occur an even number of times. Okay, but wait, what's this? Okay, I think the actual problem was something different. Okay, yeah, okay, the actual problem was given n line segments, and you need to check if if you look at the planar drawing of that, if there are 2 regions with the same distance to the ocean. Okay, yeah, just implement it. I mean, n is only 1,000, so it shouldn't be too hard. Can be done in n squared log n time, and only 250 lines of code. Shouldn't be too hard. Maybe you freak out while doing that, but anyway. Now let's look a bit at the structure of this problem, and first consider the dual graph. So the input was these colored regions, and the dual graph is just we place a vertex in every region and connect them if they are adjacent to each other. And the ocean is the outermost face, which is not directly shown here, but every region on the outside is connected to the ocean. Okay, then we want to add the distance from the ocean to every region, and yeah, the ocean gets distance 0, the ones connected to the ocean gets distance 1, and so on. So now the question, the answer is yes, if there are 2 adjacent regions with equal distance to the ocean. Okay, so it's a distance to the ocean, and we know that the distance between adjacent things can only be at most 1, so we can consider those distance modulo 2. So the green region gets distance 0 now. Okay, now the answer is no if all pairs of adjacent regions have opposite value. Okay. Now we consider that this is true if the dual graph is bipartite, like colored in this picture, and that is true if the intersection points always have an even number of lines meeting. And at this point we can see that if a line goes through a point, it first enters it and leaves it, so this will always be 0 modulo 2. So we actually only need to count if each segment endpoint appears an even number of times in the input, which is what I explained at the start. Okay, so there were 25 submissions, and thank you. Yeah, and before the freeze, no one was able to solve it. And now we have some nice test cases which we use to judge this. And I will give the presenter to Martin.
Thank you very much, Michael, for that last problem. We would like to end these solution slides with a bit of statistics as usual. It's really interesting to see that Java is quickly losing popularity over the years. C++ and Python are still growing strong. We also still had our Kotlin supporters team who solved all the problems they did. They solved it in Kotlin, so good job to you guys. And we also have these recurring statistics of jury work. We actually have almost exactly the same number of commits as last year. It's interesting. We again had over 1,000 test cases, which did quite stress our judge hosts a bit, but I think they held up in the end. We also had a bunch of jury submissions again, also from our proofreaders, almost 300. It's really fun to test out all the edge cases and test out very small bugs and see if one of the test cases fixes it here. But in any case, then, let's see, that was actually problem I. Yes, that was the most difficult problem. Good job, Michael. Also, one final fun thing. So the jury, yeah, we work very hard. Some jury members were even working until last evening. I just wanted to share their last commit messages with you guys because they were hilarious. Mace, who joined us here for the jury today, after being proofreader, he just said, "Don't look at this commit." I don't know what he did. I didn't take a look, but I guess if you want to know, ask Mace. Then Ragnar pushed the commit. Final cases to break quadratic Dijkstra for Galaxy Quest in full caps. But actually, okay, one more. And that's it from me. I'll now give the word back to Nadine, and we will have a small intermezzo before we start to the award ceremony.
Thank you very much, Maarten, and the rest of the jury. Can we have one more applause to let them know how much we appreciate them? Then I would like to thank our sponsors of this event one more time. So I would like to thank our platinum sponsors, Huawei, Jane Street, and JetBrains. Then I would like to thank our gold sponsors, Booking.com and Bending Spoons. Our silver sponsors, ASML and North Pole. And our bronze sponsors, WebTraders and Chipsoft. I think... I would like to invite our sponsors now for a word from them, and I will start with Dr. Dimitrios Papadimitriou from Huawei.
Hello, good afternoon, everyone. So I'm glad to be here with you, and also interested in sharing your results. I would like to thank everyone for your participation, the organizers, TU Delft, NWRC. We know that you have been doing a great job during all this time. We know that's all about dedication, effort, and I think that you enjoyed actually your time here. And I do believe that in this kind of efforts that you do, I hope that you had fun over all this time. I think that's probably the most important. We would like also to congratulate you for participating to our contest, and some of you who participate to the TED Talk might have had the chance to look at our Huawei challenge, and we invite you to participate too. So thanks again for all of you for your time, dedication and effort, and hope to see you next year. Thank you.
Thank you so much. And then for our next talker, I want to invite Pavel Mavlin from JetBrains. Thank you.
Hello everyone again. Very nice contest. Did you like the problems? Yeah? Okay. I want to again send my compliments to the judges. Yes, very nice contest. We solved it in the mirror contest. We managed to solve all the problems, but it was very close, yes. Problem B is my favorite problem of this year, actually, yes. I love it. Congratulations to everyone. Congratulations to everyone who got medals, who advanced to World Finals. If you didn't advance to World Finals, I'm very proud of you. So even if you're not proud of yourself, I'm very proud of your results today. Okay. Like I told you yesterday, like the most important part of the contest is to have fun. So I hope you all had fun today. Okay, and see you next year, I hope.
Thank you so much. So next to NWERC, normally we only had NWERC before the World Finals, but I have a very exciting announcement that from next year on, we also have the European Championships. So we have the first European Championships in 2024. So what does this mean? We will have a contest between the top institutions of the 4 European regions. So the 13 best institutions from NWERC, so from today, will be invited to participate in the European Championship. The first European champion under construction. So what will the European Championship offer to you? So as we already said, today we will give away 3 slots for the World Finals in Kazakhstan. But at the European Championship, still 4 World Final slots will be up for grabs. So in total, 52 teams will participate in the European Championships, which are 13 per region. So from NWERC, SWERC, CERC, and CIRC. So 12 teams will already have qualified on their respective regional, from which 3 today on NWERC. But 40 teams will compete for the last 4 guaranteed World Final slots of Europe. So basically you have still another chance at the European Championship. The invitations will be sent out to the NWERC teams starting next week. Also, your coaches that were here today at the coach meeting also know more details about the European Championship. So if you have questions, you can also ask your coach. So that was the last announcement about the European Championship. But I still want to have a small word to thank everyone today for being here. Not only you, the contestants and the coaches, but also the amazing team that worked multiple months to put this contest together and make it work today. So a lot of them are sitting there on the left, and I would like to give a very big applause for them for all their motivation, enthusiasm over the last few months to make it happen today. I hope you all had an amazing time today and that you had the most fun. So now we will go to the next part, to the award ceremony. So we will put it together now. It might take a few minutes and then we will start with the resolver. So see you in a few minutes. Red. And what do we do if it becomes green? Hey! Okay, very well. So now that we have done the practice round, great. Now the other practical matters. We first will do the resolver for the company teams. And after that, we will go to the resolver for the contestant teams. So for now, no people are coming to the stage yet. But the people that can come to the stage are, of course, the teams that win one of the medals. So there will be on the slide if you won a medal, if you won, like, become first place, second place, that. But we also have slides for first to win. That doesn't necessarily mean that you won the contest. So you're not supposed to come to the stage then. And we also have slides if you are invited for the EUC. So that's also on the slides. If you are a team that won one of the medals, then you can come via this way on the stage. Then we make a picture here, you get your prizes, of course, and then you can get off the stage on that way. So is it all clear for everyone? Is everyone excited? Yay. All right. Nice. Then we will start with the company resolver. So we had 7 company teams competing today. Jane Street, IMC Trading, Ortec, Betterby, Booking.com, ING and ASML. So, hoo-ah, hoo-ah, hoo-ay, hoo-ah, hoo-ay, hoo-ah, Yes, congratulations to the Ortec team with bronze 3rd place. You solved 6 problems. Amazing. All right. Hooray! Congratulations to the IMC Trading team for 2nd place with solving 8 problems. Well, congratulations, Jane Street team, for 1st place from the company pool with solving 10.
It's probably going to be very, very close.
Yeah.
Already before the freeze, it was already very tight. There were some teams that were really close to each other, so we're going to see. Yeah, it's loading, of course. More. Well, let's see if they did better than the company teams.
Yeah, who knows?
Oh, yeah, thank you. Yes. All right, so as it's starting up, we are heating up the monitor to unfreeze the scoreboard. Ah, okay. Yeah. All right. Ooh.
I hear some practicing going on here. Well, if you remember maybe from last year, at some point they find it very funny to wait very long. So I was standing here and I was going like, ooh, and they kept waiting and waiting, and I was like in shortness of breath, and they were just laughing there. They were just waiting to see how long I could do it.
Yeah, guilty. That was me.
Yeah.
Yeah, that should work. Oh, there we go.
All right, amazing. So we have many teams today. So the first part we go a little bit quicker, and then the second part we will go slower to make it very exciting. And if we pronounce the names of the teams a little bit weird, that's because, yeah, we're also a bit weird. So
it's intended. It's all intended. Yeah, so lots of teams joined today. It's very nice to see. So the lower are the totals. There's not a secret team that is joining that. Totals going up. Nice. Hey! Fantastic 4 going up again. All right. Hey! Control Elite, nice job. Deep Showman also going up. Team 83, nice, another one. Waltz going up. Six, total chaos. Big W notation, congrats.
Very excited scream or disappointed scream?
Now we're going up. Nice, good job.
Hey!
Nice.
Hey! Hey!
So we're closing in on the two solutions. All right. Yes. We're entering almost top 100 territory. Let's see. Gonzal succeeded. Good job. Nice. Segmentation Freud. Nice name, going up. Oh, hey.
Hey! Hey!
Hey. Lots of people going up.
Yeah.
So now we're entering the 4 solution frozen territory. So let's see.
Hey!
Closing in on the top 80. Hey! I love the enthusiasm that's just randomly happening sometimes. All right. Now we're at the top, the 5 solved territory. Nice. All right, and we've entered the top 50. Pi equals 3.14, keeping it very exciting. Hey. Wow. What do we have?
First to solve problem A. Congratulations.
Hey, nice.
Congratulations.
All right, and we continue.
Hey.
Moving up. Is it moving up? Florida man. Nice, good job.
Hey.
Hey. Hey.
First to solve problem K. Congratulations.
All right, control defeat. Oh, they won. Nice.
Hey. But advances to European Championship. Congratulations. European Championship. Congratulations. Way. Congratulations, Florida man. You go to the European Championship. Also, congratulations. Hey! First to solve problem D. Congratulations. Hey! is this one?
Huh? Wel op nummer 12 al, toch?
Ah, oh yeah.
All right, yeah, please come on stage.
Yeah.
Is Team
Team
NDE building? Please come this way on stage. Thank you very much. Congratulations.
You can get your presents first. Congratulations. If we can.
Yes. For the picture, you have to stand a little bit closer to the line. Over here. Perfect. Does that work?
And then.
All right, that was the first medalist. Let's see who's next. We have
Control Alt Defeat, bronze medalist. Congratulations.
Please come on stage. Oh, there they are. Please come this way to from the right to you. Perfect.
Congratulations.
Yes, please stand over here for the picture. Yeah, you have to stand in front of this line. Yeah, like that, perfect. And then, sorry.
Now it's getting exciting again. Ooh, but Trinity's Trinity. Congratulations with the bronze medal. Please come to the stage.
Yes, you can come stand here on this line. Yes, perfect. Thank you. And their team picture will be taken over there from you.
Give the last coach.
Yes. Yes. Please exit the stage that way. Thank you very much. Congratulations.
Now for our last bronze medalist. We have here Infinite Loopers. Congratulations. That's fine. Our first silver medalist. Ooh, seems to be okay. Come to the stage, please.
Huh? It's a big okay. It's a big okay.
It's a big okay indeed.
Very clever name. Ah, there they come. Ja.
And they have a wonderful mascot with them. I see a ducky coming on stage. Ducky alarm, ducky alarm.
It's not a rubber one this time, I think.
Congratulations. Oh.
Right. Come stand over here a little bit. Yes, come with me. Nice, congratulations, guys. Perfect. And now take a big step to the front. Thank you so much. All right. Congratulations. You can go off stage here. Congrats. All right. Then, who have we had next?
Then next, as our silver medalist, Sekvatko.
Which were also first to solve problem J, which is nice to see. And here they come.
Congratulations.
Dat valt tijdens het voorbereidingsweekend van wiskunde.
Yes.
Congratulations.
And now we can take a step forward. Oh. Congrats. Gefeliciteerd, boys. Okay. Then,
Okay. Ooh.
Ooh. Hey! Nice job. First to solve also. All right. Then we have the Structure College.
Yeah.
Yeah, there you
You have
go.
the Structure College
Silver
for
medalist.
6th place.
Please come up front.
Congratulations. Congratulations. Congratulations.
Right, you can exit the stage here. Thank you very much. Congratulations.
And then for our last silver medalists. Shame, shame. Well, I don't see any shame. Do you see any shame?
I think silver is really good.
Congratulations, shame, shame. Congratulations.
All right, you can stand next to me. Congratulations.
Thank you.
Good job. Congratulations. Yes. Now you can take a few steps forward. Perfect. Thank you. All right, you can exit the stage here. Yes. Congratulations. All right. This is
And
the battle of the top
gold
four.
medals we go.
Yeah. Well, we have at least the Trinity.
Congratulations, Trinity.
They had
First to solve problems F and G.
Yeah, you had 2 problems. That's pretty good. Right, you can come
Congratulations.
stand next to me. All right, and you can step
Shall I
forward
give you
now.
also the...
Perfect. That works. Yeah. All right. All right. Guys, can exit here.
Then we go to 3rd place. Who is
Yeah,
it
this
going
is-
to be?
This is going to be tough. Yeah. New jeans. Let's see. Did they solve B? They have 2 more chances to move up. Will they? Well, this settles place number 3, which will be kindergarten time limit. Congrats.
Well, they say time limit, so it's kind of fitting there. So congratulations, kindergarten time limit for
First-
3rd place.
And first to solve problem C. Congrats.
And a world final slot.
Yeah.
Congratulations.
Maakt niet uit.
Time to pack your bags for Kazakhstan. Congratulations.
Congratulations.
Congratulations. Congratulations. Congratulations. Okay, I think we have to...
Yes. And you can step forward to here. Perfect. Thank you very much. All right, you can exit the stage here.
Then for 2nd place, now
Congratulations.
it's getting really exciting. Who is it going to be?
It's the fight for the top 2. Let's go. Well, good job, our logo. You guys managed to get 2nd place in this tournament. Please come forward while we get your team picture on the screen. Yes, there we go.
Congratulations. Congratulations.
Yes. Please stand next to me. Congratulations. Good job.
Congratulations.
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 Yes. You can now take a beautiful step forward over here, and I will make a beautiful team picture for you.
Oh, I don't want to stand in the middle.
All right, congrats. You can exit the stage over here. Thank you very much. Congratulations.
And then, for our first place winners, gold medal winners, we have a very special prize, and I think you all can see it standing here. So congratulations, New Jeans, for first place winning NWERC! Maybe you can put that in the back? We have some logistical problems here, challenges. Too many prizes, it appears. Can you ever have too many prizes, though? There you go. I would hold it also. Yes. Yeah. It appears you can have too many prizes. There you go. Do you want to hold one or should I give it to the other coach? Yeah, all right.
Thank you.
And that concludes our award ceremony. We hope you all had such an amazing time this weekend.
We did.
We did
definitely
at least. And we would like to invite you all for our drinks, which will happen where?
It will happen down below in front of the main entrance, in front of the restaurant, the same place where there were drinks yesterday. So please join us. We would love to have you, talk to you. And if you have any feedback, any tips, any tops, let us know. We're more than happy to talk to you about anything.
And with that, I would like to thank you all so much and see you another time. Thank you.
Before you guys leave, I want to say one thing that, I mean, we have an amazing organization, but there's one person that I want to thank just a little bit extra, Nadine. Okay, please stand in the middle. Well, one big applause for Nadine for putting it all together. Without her, there wouldn't be no NWERC.
Oh, goed zo.